Hi guys, Mrs. H here. So today we're going to be looking at scatter plots and the information that we can get and learn with data from a scatter plot. So let's review what a scatter plot is. Remember, scatter plot has ordered pairs, and so we're looking for evidence to show a relationship between those two ordered pairs, like the X and the Y. So the X is one set and the Y is the second set, and so we're looking for that relationship between those two two variables. And so we also can look at things like outliers and gaps in our data when analyzing information in our scatter plot. So let's look at this set of data. So how would I set up a graph using this data set? So it's going to be a lot like a line graph. So we want to make sure we set our X and Y axis. We have labels on our X and Y axis that we appropriately identify our maximum value. So here, see we have 9 and 90. So we want to make sure we set our max values above those. We want to make sure we label our X and Y axis appropriately. And then we want to plot the data. So I've done this much so far. So if you notice that I have a title, the number of hours slept, impact on test scores. Notice right here I have my hours slept, and notice I've indicated how I'm measuring that in hours. And then test scores, and notice I have that in percentages. So the next thing we need to do with this set of data is insert a trend line. So this is obviously with the computer, and so with a computer I can automatically do that, but sometimes we don't have that ability. We don't have the computer, we're doing it by hand. So remember that best fit line is the line that represents all of the data. So it's kind of like an average or a representation of what the data is saying. And so then we can make predictions on those. So some couple of tips if we're doing this by hand. We want to make sure that if you notice, if you notice here, there's a red line, and that's the one the computer did. And then there's a blue line right here. And so notice that blue line is pretty close to the red line. And so really for me, if I'm spotting that, I'm not going to know the difference with that. But if I come over here and I draw a line like this, notice that's really not representing. This side's a little low and this side's a little high. I could also draw a line right here. That's a trend line. And again, notice that trend line is a little top heavy. And so we want to make sure that trend line is really representing the data and running through the data set. If you're doing this by hand, I would suggest using a clear ruler because you can get a little bit better a view of your data point, and then typically speaking, you get a little better of a trend line. So let's go ahead and look at sorry about that. Clear mouse. Okay, sorry about that. So no, it's not. Okay, so here we go. So now I have our data set, which we're looking for our hours slept and test impact. So I need to calculate what the slope of the line is. And so remember we did this yesterday. So we can use that equation rise over run, or y2 minus y1 over x2 minus x1. Really either is okay. So again, if I am using my data set, and I can either draw a line to 2 points, or I can find 2 points on the line. Either, again, is acceptable. I don't care which way you do this. So, mouse. Okay. No, it's not clicking. Okay, here we go. So here I have picked 2 points on the line, and that's really, really important to note that we want to make sure that the data point is on the line. So if you notice, this data set is pretty close to the best fit line, but sometimes some data points aren't falling on the line. We could have a data point over here, or we could have a data point over here. And so again, we want to make sure we're picking 2 points on the line. The second tip I would take is, if you notice, I picked points on the line that actually cross through an intersection. So in my selection, I made sure that I could easily find and determine what the number is. And that's also important. So if you're kind of estimating what the number is, that can cause some variation in our measurement for the slope of the line. So here are my 2 data points. And if you notice, I put them into the equation of the line. So I have x, or y2 minus y1, so 85 minus 55 equals 30. And then my y, or my x, so I have my x2, which is 8.5, minus my x1, which is 5, so that ends up 8.5 minus 5 equals 35. And then I reduce this because, again, I know mathematically in your math class they don't want you to have fractions. However, it really makes more sense when we're analyzing our data for our purposes to reduce it to 1 and say 8.5 over 1, because our understanding of what the data is just easier to understand. So here again is my same slope. So the next thing I need to do is I need to get my y. So my y is 7 down here. So one of the important things you always want to make sure when you're looking at your y, especially on scatter plots, that my minimums are 0. Sometimes when you see scatter plots on graphs, they'll actually chop this whole part off and actually move the graph over here. But that means our y is then misinterpreted. So again, y is the value of y when x is 0. And so our value here is 7. And so we end up with a slope of the line that says y equals 8.5x plus 7. So putting it all together, I just said that. So then our slope is 7.5, and that means my y is 7. But what does that mean? What is that saying? What can I say about this data set? And so what claim is this data making? Well, the claim is that sleep has a positive impact on test scores, right? That's the claim I'm making. What evidence do I have to support that claim? This is where the equation of the line comes in. So what does this mean? So this was my y. So my y is my test score. So I have 8.5% per hour, right? That's what that's saying. So every 8.5 hours a person sleeps, or sorry, I said that backwards. So for every hour a person sleeps, their score on their test increases by 8.5%. Or so another way of saying that is, for every 8.5 percentage points you score on a test, that equals 1 hour of sleep. And so what else can we say about this data? Well, what does this 7 mean? So that means if I don't have any sleep, 0 sleep, because that's what that's saying. If I have 0 sleep, that means my score should be a 7. What else does this data say? Well, there's this big gap over here. There's no data over here. So why isn't there any data? Well, because all of the people that we analyzed had at least 4 hours of sleep. So the minimum amount of sleep that the people were being tested had at least 4 hours. That's what this means. And so notice we can make the claim that sleep has a positive impact on test scores using the data from the graph. Now, this next part is why. Why is this happening? Well, we know that our brain functions improve with sleep. And so that's what this data is telling us. So notice how we can use the data on the graph to make claims based on the evidence that's on the graph. And so that's what a scatter plot does. I hope that this is helpful and that you have a better understanding of what we can learn from a scatter plot and how these can be very useful in science and in the science classroom. If you have any questions, please make sure you're reaching out to me. Bye, guys.